Welcome back to Infinity Beyond. In tonight's journey, we venture not just across space, but into the very fabric of reality itself. We explore the strange, beautiful, and mind-bending phenomena that defy common sense: black holes, time dilation, and the mysterious possibility of wormholes. Let's begin with the most enigmatic giants in the universe: black holes. A black hole forms when a massive star collapses under its own gravity after a supernova explosion. If the core is heavy enough, typically more than 3 times the mass of the Sun, nothing can stop the collapse. The star is crushed into an infinitely dense point known as a singularity, surrounded by a region called the event horizon, the point of no return. Inside the event horizon, gravity is so powerful that not even light can escape. Hence, black holes are invisible. But we can observe their influence: stars spiraling around them, light bending near them, and powerful X-rays emitted by gas heated as it falls in. Some black holes are stellar mass, just a few times the mass of the Sun. Others, like Sagittarius A at the center of our galaxy, are supermassive, with millions or even billions of solar masses. How they form is still a mystery, but they lie at the heart of nearly every galaxy. In 2019, astronomers captured the first direct image of a black hole, not the black hole itself, but its glowing halo of superheated gas in the M80 galaxy, 55 million light-years away. It was a moment of history, a shadow in the light, proving Einstein right once more. Speaking of Einstein, it was his general theory of relativity that revealed the true nature of gravity, not as a force pulling objects together, but as a curvature of space and time. Imagine space-time as a flexible fabric. Massive objects like stars and planets bend this fabric, and smaller objects follow those curves. A black hole is a point where the fabric is stretched infinitely, a tear in the geometry of the cosmos. This curvature doesn't just affect space, it affects time. The closer you are to a massive object, the slower time passes for you compared to someone farther away. This phenomenon is called gravitational time dilation. Near a black hole, this effect becomes extreme. From the outside, time appears to slow to a crawl at the event horizon. But for someone falling in, everything feels normal until the end. This idea was famously explored in the film Interstellar, where a planet near a black hole experiences 7 years for every hour that passes on Earth. While fictional, the science is sound. Time is not fixed. It flows differently depending on your position in space and gravity. Now imagine bending not just time, but space as well. So much that 2 distant points touch. This is the concept of a wormhole. A wormhole, or Einstein-Rosen bridge, is a theoretical tunnel through space-time. If they exist, wormholes could connect 2 separate regions of the universe, or even 2 different times. Travel through one end, and you might emerge across the galaxy, or in the distant future. Wormholes are allowed by Einstein's equations, but there's a catch. They require exotic matter with negative energy density to stay open. Without it, the tunnel would collapse instantly. We've never observed such matter, and wormholes remain speculative, tantalizing but unproven. Still, physicists study them seriously. If stable wormholes were possible, they could revolutionize travel, communication, even our understanding of causality and time itself. They are at the intersection of science and science fiction, where imagination drives inquiry. At the heart of these mysteries is the question of information. When something falls into a black hole, what happens to its information? Does it vanish forever, violating quantum mechanics? This is known as the black hole information paradox, one of the deepest puzzles in theoretical physics. Recent research suggests that information may not be lost, but encoded in the event horizon, or perhaps radiated away in what's known as Hawking radiation, a quantum process predicted by Stephen Hawking. This radiation causes black holes to lose mass and eventually evaporate over eons of time. Imagine this: a black hole, once a ravenous monster, slowly fading away until only a whisper of its existence remains in the cold, dark future of the universe. As we contemplate these extremes, we're reminded that the universe is not just strange, it's stranger than we can imagine. It stretches the limits of our understanding, bends our perception of time, and challenges the very nature of reality. But it also inspires. Black holes are not just cosmic vacuums, they are laboratories of gravity. Time dilation is not just a curiosity. It's been measured by satellites, GPS, and atomic clocks. Wormholes may be unproven, but their study drives breakthroughs in mathematics and quantum theory. These are not fantasies. They are doorways to deeper knowledge, and possibly one day to other parts of the cosmos. As this segment closes, let's pause, floating in quiet awe at the edge of a black hole. Space curves around us, time slows, and in the silence we feel something profound, the pull of wonder. This is Infinity Beyond, where science and dreams collide in the gravity of the universe.